first way is our friendly standard library function http.error, which is very simple, very easy to use. So you have your request handler, serve HTTP, that if it encounters an error, all you have to do is call http.error and pass the response writer, and then the error message, and the status code that you want to give back to the client. And this is great, and it's really simple. You just return on the next line, and that prevents any further harm from being done. But you'll notice that there's a couple problems with this, I think, and that is that you're giving the error message to the client, which isn't always desirable, especially if your error message contains details about your system. It could be kind of a security doozy to reveal that to anyone. And you also, unless your client is a log, you have no idea that an error happened, and I guarantee that your clients are not error logs. So another problem too is that the response to the client looks like this. It's rather dashing, really.
It's beautiful.
Yeah. And this actually works great if you're serving like a JSON API or something where you have automated clients. You can actually just make your response JSON text, and your client can just parse that like they always do. But this isn't very appealing if you're actually hosting a website. And I mean, you might be clever and think, well, I'll just pass in an HTML body as the message, as the error message, and the browser will render a nice HTML page. But your plan would be foiled because of the 3 whole lines that make up the error function. The first one says the content type plain text. So that won't work. And the other 2 literally just write the response. It's about as simple as you can get. So this next way is to just write your own error handler. And this is a really good way to fix some of the problems. Here you'd have your request handler that if it encounters an error, instead of calling the standard library function, you just call handle error. Pass in the response writer so that it can write the response, probably pass in the request so that you know how they, I guess, what caused the error or how you got to that point. And then, of course, the error itself. And the nice thing about your own error handler is that you can do your own logging. You can write a nice HTML response to the client, so that way you can actually know the error happened. And then, I mean, you probably want to pass the status code in instead of returning 200 OK, which is what this would do. So, but there's another problem with this. Where is this handle error function? Does it live with your handler? Your request handler? Well, it has to. Your request handler has to have access to this handle error function. And this actually might be a problem if your request handlers are shared between different applications. This is especially problematic if you're writing middleware maybe for other web applications, for Go programs to import. If you do your own error handling, that's actually not okay because it's a little bit presumptuous to assume that you know how the application wants to handle errors, something that can completely terminate the execution of your program, even. So you want to decouple your HTTP handlers in this sense from your application. Because really, this handle error, this is all application logic that probably shouldn't be living with the middleware. So one way to fix this is if you, so you have your handler struct, and let's say this implements HTTP handler, so there's a serve HTTP method. Why not just give it an error function? This is actually a really good way because the application will set up its handlers, it might set up its middleware chain, and as it creates each middleware type, just pass in its own error function. And it has to match the signature, of course, so you want to make sure that you use a signature that would get enough details so that you could handle it. For example, you might actually want to take status code. But this is a really effective way to decouple your handler from the application in a sense. But there's still a subtle problem with this. And I encountered this the last several months, and I found the answer on the Go blog. But you'll notice that if you have a handler that's malfunctioning and it writes the response when it shouldn't, or it doesn't write the response when it should, then either your client just gets a blank response, or you get maybe a corrupted response or something malformed. Either way, you have a bug because you got one shot to write to the header, to write the header out, and then you got one shot to write the body. Well, you could write the body multiple times, so that's usually a bug. So you need some way to know if you have your middlewares chained up. Let's say you have 5 of them in a row. How do you know that maybe the 3rd or 4th one didn't write the response when the 2nd one maybe was going to, or the 5th one was supposed to? I actually had a case a few weeks ago or last week where I had some gzip middleware. This poor gzip middleware was in the middle of some malfunctioning handlers, and it didn't know that. And so every time you clicked a link on the website, your browser would download a corrupted gzip file because there were partial responses and other weird things going on. So this 3rd way is actually a really interesting way to get around this problem, and that is to have your HTTP handler return a status code and error. And I know, before you freak out, I know this is not net HTTP compliant because the net HTTP signature does not return any values from its HTTP handlers. But I'm suggesting that in some cases that might be a good idea. This isn't the answer to everything though. For example, the first way or the second one might be the right way to do it in each case, but this is a good way to get around that last problem I was just talking about. Because if you return the status code and the error value, some really interesting things happen. First, your HTTP handlers look really clean. It's really clean, very idiomatic Go. If there's an error, all you do is return. There's no function call, no coupling to any application. You don't even have to think about error. The status code and the error value are completely independent, and this is important because the status code really is for the client's benefit. And you want to do something for the client differently than you would do something for the server, which is what the second return value is for, the error. So you return the error so that the server can do something with it, and you return the status code so that the client can do something. And then if everything is okay, you just return status okay. So another interesting thing that this allows you to do is if you have a chain of handlers, and they each are returning the value from the handler in front of it, this is great because now the handler that is getting the return value from a handler that was in front of it knows whether that handler wrote the response. You have a guarantee as to whether the response has already been written and what it was. Typically, if you return an error status, the response has not yet been written because all the handler did was return. If you return a status less than 400, which is an OK status or a redirect, then the response was written and you don't need to do anything. So how do you make this compatible with net HTTP, and who actually handles the errors? So this is what actually the Go blog suggested. I kind of adapted it a little bit, but they suggest creating your own handler type. That's just a function that returns, it's like serve HTTP from the standard library, but it returns the 2 values. And then you actually implement a net HTTP compliant handler that doesn't return it. And it invokes your middleware chain. It just starts off that invocation of functions. And you'll notice that it handles the status and the error that are returned. So in this case, it looks at the status, and if it was an error status, it knows that the response has not yet been written because all of the other middleware, hopefully, abide the contract, and you write the response to the client. Maybe you wouldn't want to use HTTP error, but that's the nice thing, is that this is an application level thing. You can do whatever you need to here. And then, of course, you handle the error by logging it so that you actually know it happened. The beautiful thing about this is that this keeps all the error handling away from your handlers and keeps it close to the application. And also, notice that the handlers middleware, they don't call an error function an error handling function, so you don't have a bunch of these different error handling function calls around. You have completely consolidated all your error handling to just one place. This serving too. This could be its own middleware handler that actually its sole job is just to do error handling. And we put it kind of near the end of the chain so that it knows before if any of the other handlers had an error. I found this to be really nice, really effective when you really don't know what your middleware stack is going to be like, when you're going to have to use your handlers with different applications. It scales pretty well. I've been using this for a couple months now on a project that I just released last week called Caddy, which is a batteries included cross-platform HTTP web server, and it uses this method to great effect because just by adding a line to a configuration file, it completely changes the way that the web server is supposed to serve requests, and it just changes in these handlers dynamically. So if you want to see it in action, I encourage you to check out this project. Maybe I can pull it up on GitHub here. I'll show you one. So I've actually got a bunch of really small packages here again, where each middleware is its own independent package. Oh, it's a fun one. This allows you to serve PHP sites or anything else that uses like a CGI. So you got this handler type. And notice that it takes the next handler in the chain. And there's nothing here about error handling really. This is all just state that it needs. So here's its handler. Notice that it returns the status code and the error. All you do if you encounter a problem is return the status code and the error. Status code and the error. There's a whole bunch of things that could go wrong. CGI is, well, you know. And then at the end, once it's written the response, it returns a non-error status, and then that error, of course. And this is an example of how it would just propagate the values back. And there's actually a dedicated error handling middleware. I saw it over here. Called Errors. That again, it's just a handler, and its sole job is just check the status code and the error, and then again, if it's an error, it just logs it. If it's an error status, it gives that back to the file. So this is the only place that error handling really occurs in the whole application, as far as HTTP requests go. Even though there are well over a dozen middleware layers, and there's more coming as well. So anyway, those are the three ways that, I guess, three really good ways you can handle errors.